Good morning, friends. Yesterday we have completed the topic power set and JEE questions related to the power set. There are many JEE questions in various different forms or various ticks. Now we are going for the next topic. This one is also useful and important topic for 11th science as well as 12th science. This topic is very important for 12th science also. So see here, and this topic is new for you. Okay, then complete concentrate on this topic. The topic is intervals as a subset of R. The topic name is intervals. Now what do you mean by intervals? So there is the definition of intervals. For the definition we are going for the some assumptions. First one assumptions is A and B, which are two numbers from set of real numbers. Okay, set of real numbers means A and B belongs to R, it's real numbers. And A less than B is the important condition. A less than B is the important condition here. Always A must be less than B. Now, by use of these conditions, we are going for the representation or studying the intervals as a subsets of R. How we will define intervals? But first question arises, what is interval? And what is the use of interval? Okay, sometimes we do not need. The use of intervals is very important. Sometimes we do not need complete set of real numbers. We only require numbers which are in particular zone. Suppose I want numbers which are lies between 0 and 2. All the real numbers lies between 0 and 2. Then we don't require the other rest numbers of set of real numbers. Then we have to use all the numbers lies between 0 to 2. Then we require intervals. Now we will study the interval. The definition, the set of numbers x such that A less than B is called an open interval. Now see here, we have to list out all the x such that A less than x less than B. Okay, that means all x lies between A and B. Here A is less than B, therefore A on number line always left hand side. On number line, the A is left hand side of B. Okay, and B is the right hand side of A. Therefore, we required all the x such that A less than x less than B. That means all the x lies between A and B. All the x lies between A and B. Here x belongs to R is condition. It is not given here. If the condition x belongs to R is not given, then you have to take by default. Okay, then the condition which is not given here, but the condition you have to consider if x belongs to R. Therefore, all the real numbers lies between A and B. All the real numbers lies between A and B, which is represented as open interval, and the notation for this is open interval A to B. This is the notation, open interval A to B. This means this. Okay, all the real numbers lies between A and B. Okay. Now, the interval which contains the end points. Say here, in this case, A and B are the end points of this interval. A and B are the end points of this interval. But here we can't consider x equals to A because equal to sign is not there. Also, we cannot consider B x equals to B because equal to sign is not there. But if we want A and B both, then we have to put equals to sign here. Then the interval is known as closed interval. The interval which contains the end points also is called as closed interval. It is called as closed interval, and the notation for closed interval is square bracket A to B. Square bracket A to B. The square brackets represents x equals to A as well as x equals to B, and all the x lies between A and B. Okay, so there are three conditions here. We have to consider x equals to A, x equals to B, and all the x lies between A to B. In this case, we have to consider all the x lies between A and B. All the x lies between A and B. Okay. Now, this closed interval can be represented as in set builder form or property method, like closed interval A to B equals to x such that A less than equals to x less than equals to B. Okay, that is condition x belongs to R, which is not written here. Okay, A less than equals to x less than equals to B. So we know that less than equals to is there, therefore we have to include A as well as B. Now, there are two different open intervals like A to B equals to x such that we have to include A but not include B. Therefore, we can represent in set builder form x such that A less than equals to x, A less than equals to x less than B. A less than equals to x less than B is an open interval. It is known as open interval because B is not included here. From A to B is known as open interval from A to B, including A but excluding B. But we can't include B here. Okay. Now the fourth one, which is A to B, which is equals to x such that A less than x less than equals to B is an also open interval from A to B. Is an also open interval from A to B, including B but excluding A. Including B but excluding A. Now, the representations of the above four type of sets on the real number line is here. Now, we can represent these sets in the real number line. First, open interval A to B excluding A and B. We can read as open interval A to B excluding A and B. Excluding A and B. It is also written in set builder form x such that A less than x less than B. Now, what is the representation of this interval on number line? For excluding the numbers, first of all, this number is A and this number is B. We know that A is always left hand side of B because A less than B here. Now, Here A and B both are excluding numbers, therefore you have to put the hollow circle. You have to put the hollow circle or polo round. Okay. Next, and we want all the numbers lies between A and B. All the real numbers lies between A and B, but not include A and B. Okay. Clear? These all numbers are in set open interval from A to B. Okay, this is the representation of this interval on number line. Now the second one, open interval from A to B including B but excluding A, which is written in set builder form x such that A less than x less than equals to B. Okay. Now see here, A and B are there. Here A is not including number, therefore we have to put the polo circle or hollow circle here, and B is included here, therefore put the dark circle or complete circle here. Okay, the dark circle for B represents B is included here. Okay, this is polo or hollow circle, and all the real numbers lies between A and B. All the real numbers lies between A and B. Therefore, this and this are the portion on the number line which represents the interval A to B. Next, third one, open interval from A to B including A but excluding B. We can also represent in set builder form x such that A less than equals to x less than B. On the number line, we have to include A but not include B. For including A, we have to put the dark circle here, including A, but excluding B, we are putting polo circle here or hollow circle here. And the numbers all real numbers lies between A and B, which are on number line. Okay, so this portion as well as A are the representations on number line of this interval. Now, the last one, closed interval from A to B, which is in set builder form x such that A less than equals to x less than equals to B. So here A and B both are included, therefore put dark circle on A as well as on B, and include all the real numbers lies between A and B. All the real numbers lies between A and B. Now, the next one. Now, the next one. If set A equals to as an interval form, open interval 1 to 5, that means all the real numbers lies between 1 to 5. Lies between 1 and 5, not included 1 and 5. It is clear? Here 1.1, 1.01, 1.001, 1.00001 is there, as well as 4.9999 is there, but 1 is not there and 5 is not there. Okay, this is set A. And set B equals to close interval 0 to 6. Close interval 0 to 6. We know that we have to write less number or smaller number on the left hand side and bigger number on the right hand side. So see here, smaller number 0 and 6 is bigger number than 0. 0 to 6, which is closed interval. Therefore, you have to include all the real numbers lies between 0 and 6. All the real numbers lies between 0 and 6, as well as 0 and 6. You have to include 0 and 6 also. Now, then A blank B. Then A blank B. Which symbol is here? If subset is there, does not subset is there. So here 1 to 5. All the numbers lies between 1 to 5. The set A is here. And the set B is all the real numbers lies between 0 to 6 as well as 0 and 6. Therefore, we can say that all the numbers of set A lies in set B. Therefore, A is subset of set B. Same as the second question is given. If open interval -3 to 5 and B equals to -7 to 9. See here A set consists all the real numbers lies between -3 to 5. All the real numbers lies between -3 to 5. Okay, excluding -3 and 5. And the set B including all the real numbers lies between -7 and 9, including 7 and 9 also. Therefore, all the numbers of set A are in set B. Therefore, we can say that A is subset of B. A is subset of B. Now, the next one is important topic. The next one is important topics. Some important sets as interval form. Some important sets as interval form. The first one, the set of negative real numbers. The set of negative real numbers. So we know that the set of negative real numbers, that means all the numbers which are the left hand side of 0. All the real numbers which are the left hand side of 0. Therefore, we can represent these all numbers. Suppose this is 0. We can represent all the negative real numbers on number line like this. Okay? The left hand side, all the real numbers of left hand side of 0 represents the all negative real numbers. We have not included 0 here. Therefore, hollow round is there. Okay? Hollow round is there. 0 is not included here. Okay? 0 is non-negative numbers. Okay? It is not negative number. Now, how can we represent this form in interval form? So here the number is going towards the minus infinite. Therefore, we are using the left hand side number which is minus infinite, and on the right hand side 0 is there. Okay, from minus infinite to 0, all the real numbers lies between minus infinite to 0. Okay, now you can not include 0 here, therefore open interval on that side. Now minus infinite, here infinite is undefined number, which is not proper number. Therefore we have to put open interval or small bracket for infinite side or complete. For infinite side you have to put open bracket or small bracket always. Okay, because infinite is not defined proper number. Clear? It is the reason why we are using a small bracket here. Next one, the set of positive real numbers. The set of positive real numbers. The set of positive real numbers are 0 to infinite. 0 to infinite. But we don't have to include 0 here, because 0 is not positive number. It is neutral number. Therefore, on the number line, 0 is here, which is in hollow circle. Okay, and all the right side real numbers represents all positive real numbers. Okay, on the number line, the dark portion represents the all positive real numbers. Therefore, we can write this as interval form, 0 which is not included here, as well as 0 to infinite. Here infinite is there, therefore we have to put small bracket here. Next one, the set of real numbers. The set of real numbers means whole number line is there, from minus infinite to plus infinite, all the real numbers are there. Here on the number line, all the real numbers are there. Okay, all the real numbers are there on the number line. Therefore, we can say that all the numbers lies between minus infinite to plus infinite. Therefore, we can say that the interval can be written as minus infinite to infinite. Here both the side small bracket is there. Next one, the set of non-negative real numbers. Set of non-negative real numbers. Non-negative real numbers means the numbers which are not negative. Which are not negative. We know that all positive numbers and 0 is included there, because 0 is non-negative number. 0 is non-negative number. Therefore, on the number line, suppose this is 0, you have to dark it because 0 is included here, and all the positive numbers on the number line, all the positive numbers on the number lines are the non-negative real numbers. And the interval form of this is 0 to infinite. Here 0 is included there, therefore square bracket is there. 0 to infinite. Infinite is not proper defined number, therefore we are including the small bracket here. Clear? Now we are going for the representations of intervals in set builder form or conversion from set builder form to interval, as well as interval to set builder form. Now see, for example, the set x such that x belongs to R minus 5 less than x less than equals to 7. We know that all real numbers lies between minus 5 to 7. We do not include minus 5 but include 7 here. Okay, so it is written in set builder form. Now the interval form of this set is minus 5 is on open side and plus 7 is on closed side. You have to include plus 7 but not include minus 5. This is the interval form. This is very simple questions. The interval form minus 3 to 5. Here we have to include minus 3 but not include 5. Can be written in set builder form like x such that minus 3 less than equals to x less than 5. There is no need to write condition x belongs to R here, because by default the condition is x belongs to R. The important question or the important topic, the length of any of the interval, a to b, here b is included, a to b, here a is included, and a to b, a and b both are included, is equals to b minus a. You have to subtract a from b, means b minus a represents the length of interval. It is represent the length of interval. Suppose the length of interval 2 to 5. If we want to find the length of interval 2 to 5, then it is equals to b minus a, means 5 minus 2, which is equals to 3. The next one, the length of interval minus 3 to plus 3 here minus 3 and plus 3 both are excluded here, not included, which is equals to b minus a. b is 3 minus minus 3, 3 plus 3, which is equals to 6. The length of interval is a small topic. Now we are going for the exercise 1.3 question number 7. Write the following intervals in set builder form. Write the following intervals in set builder form. Here we are writing in set builder form and we are also represent these intervals on number line. Okay. The first question is minus 3 to 0. The open interval from minus 3 to 0. Here minus 3 and 0 both are not included here. Therefore, we can represent it in set builder form like x such that minus 3 less than x less than 0. This is the set builder form of this interval. And on the representation of this on number line is like here minus 3 is there and 0 is here. Okay. Now we have to include all the real numbers lies between minus 3 to 0. Don't include minus 3 and 0. Therefore, hollow round or hollow circle is there. Okay. Next one, 6 to 12. We can represent in set builder form like x such that 6, we have to include 6, therefore less than equals to sign is there, less than equals to x less than equals to 12. This is the representation in set builder form of this interval. On the number line we can represent these two numbers. Here 6 is there, suppose 12 is here. You have to include 6 as well as 12. Therefore, you have to put the dark circle here and all real numbers lies between them. All real numbers lies between them. Next one, 6 to 12. You have to include 12 but not include 6. Therefore, the representation of set builder form of this interval is x such that 6 less than x less than equals to 12. Okay. On the number line we can represent it like my 6 is there, 12 is here. We have to include 12. Therefore, dark circle on 12 and hollow circle on 6 and all the real numbers lies between them. Okay, this is the representation of this interval on number line. Next one, minus 23 to 5. Here you have to include minus 23. Therefore, x such that minus 23 less than equals to x less than 5. Less than equals to x less than 5. On the number line, we can represent it minus 23. Suppose here and 5 is here. We have to include minus 23. Therefore, dark circle on minus 23 and do not include 5. Therefore, hollow circle is there and all real numbers lies between minus 23 and 5. Okay, this is the representation on number line. You have to do the extra questions 1, 2, 3, 4, 5 on your self practice notes. Clear? Exercise 1.3 question number 6. Write the following as intervals. You have to write this set in interval form. So see here, first question is that x such that x belongs to R, who minus 4 less than x less than equals to 6. You have to include 6 but not include minus 4. Therefore, we can represent like minus 4 to 6 here. Okay, you can also represent this on number line. On the representation of this on number line is minus 4 and 6 is that we have to include 6 but not include -4, therefore hollow circle is there, and all the real numbers lies between -4 and 6. So this one is the representation of this interval on number line. Okay, next one, question number 2. X such that x belongs to R, -12 less than x less than -10. You can write in interval form -12 to -10. Okay, on the number line you can represent -12 and -10 here. Okay, here both are not included, therefore put hollow circle on both the side, and all the real numbers lies between -12 to -10. Okay, next one, the third one, x such that x belongs to R, 0 less than equals to x less than 7, 0 less than equals to x less than 7. We have to include 0 here, therefore put square bracket on 0 side and 7 on small bracket. Next, the representation of this set on number line, we have to include 0 here, therefore put the dark circle on 0 side and hollow circle on 7. Okay, so this one is the representation on number line of this interval. Next one, the fourth question, x such that x belongs to R, 3 less than equals to x less than equals to 4. So the representation in interval form is 3 to 4. All the numbers lies between 3 to 4 and including 3 and 4. Now on the number line we can represent, this set. 3 is included here, therefore put the dark circle, as well as 4 is included here, put the dark circle, and the real numbers lies between 3 to 4. Okay, this is the representation of this interval on number line. Okay, I am giving the worksheet today related to this topic. You have to complete it and submit on the link given in your WhatsApp group. You have to complete these notes as well as worksheet, then send all files in PDF format on the given link. Okay, thank you very much.